Thank you very much. So thanks for having us. And first of all, I'm really glad on everything we have seen so far, and I'm already looking forward to trying out what we've just seen, what Paul explained. And let's say, when performance metrics and user experience come together, why that? I come from a physics background and have been dealing with time series, let's say, not my entire life, but the last 10 or more years. And I basically come more from a pandas, scikit-learn, and Python background. And being in medicine, it's like, yeah, at a certain point in neuroscience, you do these studies, you scan 8 subjects, and then you infer something on population level. Data is never enough. So I wanted to move somewhere else and was looking for a company that had a very strong open source philosophy and that also had data, and knew something about databases. This is how I met Wirth Phoenix. Having a male audience, I think Wirth is something that almost anybody knows about. Does it know here? Maybe other. Fine, it's a company headquartered in northern Italy. It's an IT and consulting company, and we are part of the Wirth group. It's European-wide present, and we have more than 160 highly skilled employees. It's basically international experience in business software and IT management. Our core competencies are in trading processes, wholesale distribution, and logistics. And we're also a Microsoft Gold certified partner, IT certified, or TRS preferred partner, and so on. Our mission is we want to improve business productivity by delivering world-class software solutions with a team of highly motivated and skilled IT experts. So basically, we already have or had many monitoring solutions. And why did we move to Grafana and InfluxDB? We're using it in quite a few contexts. We're doing IoT projects. We are, let's say, partly integrating in our solution, simply for having much nicer graphs than before. And today I want to bring a problem that was posed to myself like 2 years ago, and they explained to me, you know, most of our customers actually have a business-critical application. What is that? That means an application that if that does not work, they cannot do invoices, they cannot sell their items, they are having trouble. And it costs a lot of money if there are performance problems with such an application. But it's not trivial to monitor a business-critical application because it's not the application itself that one needs to monitor, but it's based on many parts, like you have software parts, hardware parts. Maybe it needs to retrieve some data from the cloud or send it there. You have the user interactions. You cannot control them completely. Then it might be actually run somewhere where there's virtualization underneath, and your internet connectivity might also influence it. So you would need to cover like so many small parts that you do not even know where to start. Best thing, obviously, would be to avoid these problems proactively. And that's where I started. Like, I started talking to somebody who had analyzed time series for about 20 years, but with that in mind. And I came more with my mathematical background, and we thought it was like really a strange experience, but then we started learning each other from the other. Let me talk how he was basically doing it. He had many tools, like smaller tools, Windows tools, homemade tools, and he was extracting performance metrics from all of them. Like he had time series that he could only see with this tool and tried to scale them one way. Then he had this other tool, and like he lost so much time in simply getting everything that might be relevant for understanding whether there is a problem or there might be a problem together, that already half a day was gone before he really could do the analysis. And this is what we wanted to improve. Before we come to monitoring, let's come to time series. Given that I come from biomedical field, I bring you this. If you show a curve like that to a doctor, he cannot tell you, yeah, you're well, because we are lacking a scale for the x-axis and a scale for the y-axis. And he also wants to know something else about you, most probably. about whether you're pathologic, whether you're doing sports, like your curve yesterday after the party or after having been into a coffee shop. Might have looked differently, but nothing to worry about. We would not have needed an alarm for that, basically. To say this, that it's not a good idea to have a look at a curve on its own, but every curve or time series needs to be interpreted in the right context. For this, it might be useful to use historic data from, for example, the same person, and on population level. Like if a doctor knows, basically, a person of that age with that pathology should have a curve like that, then he can make diagnosis. Then he can actually create alarms. He knows when it gets critical or when he should put a warning there. So from these two elements, we can build our expectation for the shape of the time series itself, and where our alarm thresholds should be. Partly also true for performance monitoring of, for example, percentage of processor time. Like if you have a curve here, in this case, about 4 weeks, so a whole month of processor time, it's not the curve on its own that is critical or not, because a high value is much more critical if there are no transactions or batch requests that explain this higher load of the system. So also there we can actually take machine or setting-specific historical data and data from similar machines or settings and create kind of an expectation and results on that. What I've seen so far is that, unfortunately, in many places, it's still that you see each series on its own. So basically, you have a look at this. OK, here's an alarm, so this isn't critical, this not, and then you are, let's say, summing the alarms and making some rules on them. And we really want to move away from this philosophy. Like, we want to go more in the direction of multivariate data analysis, where everything gets kind of a state. So I do not say machine learning, but let's say it is machine learning. So all the time series, by analyzing them together, characterize actually the state of your system. By meaning that it might be once a single time series that creates an alarm, but something as a constellation might also be able to create one. So traditional thresholds are then calculated dynamically via baselining and, for example, an anomaly detection or other stuff. So an anomaly score, for example, might be calculated for each data point, and you know, is this critical or not? And then you can use this in addition to your global alarms or specific alarms that you had before. This way, you can take the relationships between the time series into account and create more reliable alarms and, for example, estimate risks. And you can also take the shape of the time series into account and maybe do some kind of forecast what you expect and compare what you're actually getting with what you thought that should have been there. Our motivations were that we wanted all these different metrics in a single data source, and we had no doubt about InfluxDB at that point because we already had made good experiences with it in other contests. So then for Grafana, everybody liked it from the very first day that we introduced it to the lab, so no discussion there as well. And that is how we then went beyond common practice and tried to be more proactive. For saying, nowadays, nobody needs a big alarm when you already have a heart attack. It's more the progress when you know that you are evolving in that direction that you want to communicate to the customer. So this is something that then came out of this first collaboration between a math person and somebody who had monitored his whole life. Like, we're showing a smooth mean and are also giving the possibility to change this smoothing. We are showing the range in which the values move in the time. Then we are always comparing it to historical data, because when somebody discovers something in the data, usually in our world, he wants to know immediately, is that an effect that simply happens only today? So is there a significant change with respect to data from a week ago or a month ago? Or is it something that happens all the time and for this is maybe to be considered in a different way? So that are the basic elements, and then we also wanted somehow to show the output of the anomaly calculation in the dashboard. So we started highlighting in different shades of red where there might be potential problems and so on. Here you see we obviously are then not looking at only a single metric at a time, but many together. And, for example, the output of the anomaly score will be the very same for each of them, so we have some kind of reference, because this has already done what the human expert would have done in the past. Like, it analyzed actually many time series together and found a constellation that, as such, was something different, rare, or strange. And for this, we basically marked it so that the human expert that is working with that data knows there. I need to go there. I look first because there, mathematically speaking, might be something necessary to investigate. And this is more or less for effect quantification, something that is really fast, because otherwise you can imagine that the human expert actually was there with one time range, there with the other, and tried, okay, mathematically, that much difference, and it took time. Now we come to user experience. What is user experience? User experience is defined as the overall experience of a person using a product, such as a website or computer application, especially in terms of how easy or pleasing it is to use. Basically, it's whether your user in front of the PC gets frustrated or not. And how can we monitor such a thing as user experience? We need to do it visually, because usually humans actually look at graphical interfaces and interact with them. We need to do it synthetically. We cannot place real people there, so the solution should behave like a human. And to monitor, actually, we need to track the transaction performance then. Our company had already an existing open source solution for that, which is called Alivix. It basically has integrated computer vision, and you can, let's say, design test cases. They are nothing other than they mimic the user behavior. Usually, all the customers know more or less what their users are doing. So they know they will definitely, once a day, open the part of the program for the invoices. They will maybe perform this certain operation. And by speaking to them, we can define if all these steps work fine, then most probably the system is up. And if they are also fast, then most probably we have nothing to worry about. But as you can see here, graphically speaking, it was a nightmare, and you were overflooded by information and could not navigate it, and let's say, to manager, you could not even show it. This is how it looks now. So we have our Mr. Alivix. We have, for example, the cumulative test performance. For example, these 4 dotted lines is how the test has behaved these 3 times. And here, for example, we got a timeout. There something was not possible at that time. And here we have instead the real performance of each transaction of the test, and we order them by transaction groups. And we do it not from a single probe, like we have installed on several virtual machines, and can, for example, place one in Germany, one in Italy, or one on one level of the building and one on the top, and measure whether the user experience of the company users is the same from everywhere. Feel free to go to the page and play with it. It's open source. You can download it and write your own test cases and test your system. Now let's performance metrics and user experience actually come together. So while before we registered the performance metrics for the IT operation analytics in one way and the Alivix separately, now everything is going to one centralized InfluxDB. And we are really happy about this, that heterogeneous performance data now is all in the same place. Like when you do troubleshooting or have anything, then you know this is where to look for it, and you do not have to open that many tools and get the data from many, many places. Then we are very happy about multi-level dashboarding because it's making troubleshooting much faster. For saying the same data are visualized in many different ways, depending on whether it's the manager that is giving a quick look on it, or whether it's the real person that is digging there and wants to find what the real problem is. We always have the historic data at the hand for the easy effect quantification, and given that we already had some of the routines ready, we are also using external scripts which do machine learning, anomaly detection, and so on. So this is how it can look like. For example, in this case of this customer, we are having, let's say, 16 servers. There we see whether at the moment there is happening something strange. For example, here, one of them actually has more potential anomalies than all the other. We also combine it with batch analysis, so data that come from somewhere else. We see whether there is something overdue. And beneath here, we have 3 probes that are reporting how user experience at 3 different places of the company is at the moment. Given that they are all up, you can be happy. Given that they are taking longer than usual, maybe you could investigate. And by combining then everything you have in this dashboard, you can basically decide where to go first, whether to start on a user experience. For example, if something is happening there, then most probably you want to know why. You can go via link into different levels and really see on which AOS it's currently running, so you can make an analysis of that machine first, or simply combine it together with the anomaly detection, see its machine X, epsilon, Y, Z, and dig there first. So this is, let's say, the scheme of it. Here you come from the overview level, where you have everything together, to a multi-measure level, and then even to a more detailed level, but not that many people are really going there. Let's say it's more our human expert that then goes there if somebody from the company is actually saying he found something, or at the moment his users are complaining. For the LWX, the very same data, for example, might look like this, or like this when you are doing statistics, or like this if you really want to trace every single transaction and know how long it took, and so on. In troubleshooting, then, you are moving around. So this is the second level, and we go further down to the third one, have, again, the historic data, and basically, in this case, for example, can find out that what happened here was basically a long-running transaction that blew up the version store. In terms of machine learning, what are questions that our customers are interested in? For example, what I've already shown, like this anomaly score, where you actually start with metrics, then model the standard behavior with the trained data, and use historical data from the same metrics, similar metrics, and similar machines. Then formulate what do we expect, and measure how far are we from our expectations, and then somehow give that back in a way to the customer that he actually can interpret and use. Another issue is maybe using not that many metrics, but all I/O-related metrics. For example, if you are thinking about a system with many virtual machines and everything is slow, then you can never really control and check every single one. So we also are using the machine learning or the anomaly detection to make out which of them are the most promising to analyze first, which could cause all the trouble. There we use, again, historical data of several sources, and then we try to individualize sets of machines that are most probably causing a high anomaly score, and therefore maybe those that we should analyze first, because if we already discover a problem there, then we do not need to check all the others anymore. Here, what I wanted to say is that we obviously followed the different versions of Grafana and InfluxDB so far. We are really happy that in 5.0 we are getting the folders and the groups, and are hoping that also the LDOP integration is coming soon. It would be really handy to be able to also transport something like min and max values as variables, or even a unit from one dashboard, from one level to another, because sometimes you have dashboard that you can actually use for many metrics, but they have different units. And in that case, to recycle the very same, for example, when you come from them where they already have different units, it would be handy to also pass this as a variable. And for the minimum and maximum values, if not possible as variables, then at least that when you are using the repeat function, given that you have said that it will remain alive for rows and panels, it would be cool to say everything that is repeated has common scaling, because then you can compare it. Otherwise, if you are using it for almost the same thing but on different hosts, if the scaling is different, or you put something fixed there and then this needs to go for everybody, or you have something dynamic that is based on all of them. And something still different is that from time to time, we have time series that we actually do not want to visualize. Like you have one that you want to visualize, but it would be really handy in that menu if you could also put others there that only appear here. Like you can do it at the moment if you are hiding them and setting the point size to 0 and no line and so on. But then they are still somehow hidden, and by hovering you see them. Or you might have something, if I think about the annotations that you can now do with the range, that you do not only want to know when it started, but that you want to know also when it ends by going over it. Because at the moment, I think you have the timestamp and you see the range, but if you want to know where it actually arrived, you need to scroll there and see the timestamp of that point. And usually, if you are having overlapping events, or also just two time series that have something significant in that event, then it would be cool to know, okay, it's falling inside because it's something between the start and end. Some questions about? Thanks a lot for listening.
Thank you. We do have time for questions if there are any. Feel free to just raise your hand and I'll bring a mic over.
Just a quick question about, and I'll check it on your site, but the Alverics that you were mentioning, that you might do it on a virtual machine or at the top of a building, a bottom of a building. Are you also running it in a non-virtualized environment? Does it run on a small system?
I think so. We are currently more having really huge virtualized installations, but I do not exclude that you also could use it in something much smaller without virtualization.
Okay, sure, thanks.
Now I feel like I'm just getting a microphone for something that doesn't deserve it. Are those real people you work with?
Yeah. 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 Feel free to come to our blog so you will find out. It's a cool company full of really creative minds, and the best thing is when actually people from different fields, like it also happens today and yesterday, talk to each other, because then they understand the needs that we really have.
Thank you.